Hi everyone. So in this video we are going to see about what is Ohm's law and what are the applications of Ohm's law. So this slide revisits the basic electrical quantities already learned: voltage, current, resistance. Ohm's law does not introduce a new concept. Instead, it connects these three quantities mathematically. Without understanding them, applying Ohm's law becomes confusing. So as a real-time example, before calculating electricity bill units, we must know power and energy. Similarly, before Ohm's law, we must recall voltage, current and resistance. So this slide explains why Ohm's law is important and what will be covered. So why we need Ohm's law, relationship between V, I and R, mathematical forms, triangle method, real world example, applications. So Ohm's law is the foundation for circuit analysis in a DC circuit. As a real-time example, an electrician does not randomly choose wire thickness. He calculates current using Ohm's law to avoid overheating. So definition of Ohm's law. Ohm's law states that at constant temperature, the current through a conductor is directly proportional to the voltage applied across it. So this means increased voltage, current increases. Decreased voltage, current decreases. Resistance controls the amount of current. As a real-time example, when we increase fan regulator speed, voltage increases, current increases, fan rotates faster. A mobile phone charger gives constant voltage, so current adjusts automatically. So fundamentals of voltage, current and resistance. Voltage V, electrical pressure, pushes electrons, unit is volt. For example, 230 volt AC at home socket, 5 volt for mobile charging. Current, flow of electrical charge. So the unit is ampere. For example, heater draws high current, LED bulb draws very low current. Resistance R, opposition to current, unit is ohm. For example, nichrome wire in heater has high resistance, copper wire has low resistance. Ohm's law, mathematical relation. Ohm's law equation V equal to I into R. V equal to IR. So from this equation, voltage depends on current and resistance. If resistance increases, current decreases for same voltage. So real-time example, if a 12 volt battery is connected to 6 ohm resistor, current is 2 ampere. And in turn, if 12 ohm resistor is used, the current is 1 amps. So same voltage, different resistance, it provides a different current. So Ohm's law triangle, finding unknown quantities. The triangle is a visual memory tool, cover the unknown quantity. So use remaining values to calculate. Formulas V equal to IR, I equal to V by R, so likewise. So real-time example, if a device works at 5 voltage and draws 0.5 ampere, resistance equal to 10 ohm. So this helps engineers select the correct resistors. Ohm's law, DT empathize space. So this slide addresses student learning difficulties. So confusion between V, I, R. Difficulty rearranging formulas and fear of numerical problems. So the goal is to understand student pain points, not just teach the formulas. So real-time example, just like learners confuse speed, distance, time, students confuse voltage, current, resistance initially. Ohm's law in a DT defined phase. So this slide defines the core problem. As students struggle to apply Ohm's law in real circuits despite knowing the formula. Solution is uses triangle method, use real-time examples, practice numericals and relate to daily appliance. So real-time example, learning to ride a bicycle is difficult until practice replaces fear. Same with Ohm's law. So the next comes is the applications of Ohm's law in real world. So Ohm's law is used everywhere. In mobile chargers, current as a current limiting, the Ohm's law is used, and in LED circuits, it's used like a resistor selection, and in electric heaters, it is used in power calculations, and in automobile wiring, it is used as a wire thickness selection, and in power supplies, it is used to voltage regulator. So voltage regulation is nothing but it provides a constant voltage irrespective of the incoming supply. Okay. So voltage regulations are now needed because the constant supply is needed for some electrical equipments. For example, plus 5 volt or plus 12 volt. So it provides a constant power supply. Voltage regulators are available. So voltage regulators regulate positive as well as negative power supplies. And in embedded systems, mainly used safe component design. So these areas are used as Ohm's law in a well-defined manner. So Ohm's laws are not just an exam topic, it is a daily engineering tool. So every electrical calculation from a torch to an electric vehicle starts with Ohm's law. Thank you.